Disclaimer: we are not professional chefs.
Egg proteins change when you heat them, beat them, or mix them with other ingredients. Understanding these changes can help you understand the roles that eggs play in cooking. Proteins are made of long chains of amino acids. The proteins in an egg white are globular proteins, which means that the long protein molecule is twisted and folded and curled up into a more or less spherical shape. A variety of weak chemical bonds keep the protein curled up tight as it drifts placidly in the water that surrounds it.
When you apply heat, you agitate those placidly drifting egg white proteins, bouncing them around. They slam into the surrounding water molecules. They bash into each other. All this bashing about breaks the weak bonds that kept the protein curled up. The egg proteins uncurl and bump into other proteins that have also uncurled. New chemical bonds form, but rather than binding the protein itself, these bonds connect one protein to another.
After enough of this bashing and bonding, the solitary egg proteins are solitary no longer. They formed a network of interconnected proteins. The water in which the proteins once floated is captured and held in the protein web. If you leave the eggs at a high temperature too long, too many bonds form and the egg white becomes rubbery.
Beating or whipping eggs exposes air bubbles to egg whites. This exposure allows the unfolding of the egg proteins just as heating would unfold these proteins. Egg white proteins consist of hydrophilic and hydrophobic amino acids. In other words, some amino acids are attracted to water while others are repelled by it. Prior to uncurling, the hydrophobic amino acids are located in the center airway from the water, while the hydrophilic amino acids are located closer to the water. When the egg white protein encounters an air bubble, part of the protein is exposed to both air and water. This causes the protein to uncurl so the hydrophilic and hydrophobic amino acids can be located in its desired respected area. This allows the amino acids to bond with each other, creating a series of bonds that hold the air bubbles in space. When heating the air bubbles, the gas inside them expands. Often the area around the bubble solidifies, and the structure usually does not collapse when the bubbles burst. The protein that lines the outside of the air bubbles is known as lecithin. This is what prevents them from collapsing when baking. This allows for the consistency found in souffle or meringue. The more whipped the egg whites are, the more stiff they will become. On the other hand, unbeaten egg whites often allow the lecithin as a binder which hold the egg together.
Here's an interesting fun fact. There's a myth stating that copper bowls are better for whipping eggs. There is some actual scientific support to this myth, proving that it is true. The copper ions from the bowl combine with cannabinoid, one of the proteins found in eggs. This combination forms a bond that is stronger than the protein itself, making it less likely for the egg white proteins to unfold. The copper could also react with sulfur-containing groups on the proteins found in eggs, making the egg proteins even more stable.